Okay. Right, so hello. Yeah, I'm Alex. I'm from a very small non-profit based in the UK called Then Try This, where I am funded by UKRI to investigate algorithmic patterns as part of a fellowship. I'm here to talk about live coding. I've got that wrong. It should say from Konnakol to live coding. So I'm looking for ways to be inspired by Konnakol to develop my live coding practice. I don't know why I got that around the wrong way. I think it's okay on my paper. So the software environment for this talk is TidalCycles, written in Haskell, and Strudel, which is a port of Tidal to JavaScript. So that runs in a web browser. I kind of think of them as the same project. I work on the representations in Haskell and then port them to Strudel with all the kind of libraries that JavaScript affords. It's free open source. Lots of people use them around the world. Don't know how many. But it's for performing with generally musical patterns as pure functions of time. And I'll sort of refer to these two systems interchangeably. I might try and go full screen there. So the aim of this is to design new support for stepwise pattern making within cyclic talas. I'll try and explain that a little bit later. Inspired by South Indian music, specifically this practice called Konnakol, which is a very advanced practice developed since around the year 200. Involves non-lexical syllables, i.e. Kind of nonsense syllables related to strokes of the mridangam drum. So has some relationship with sort of speaking drum strokes, where the syllables represent particular articulations of this two-headed drum. So these syllables, here's some of the kind of traditional groups of syllables. These groups of syllables are known as solkatu. And they are identified by the number of syllables in them in this list. So tadaginatom has 5, tadaginatom with gaps has 7. These aren't all of them, this is just like a selection. And they kind of relate to the mridangam drum. There isn't a one-to-one mapping, but it sounds something like this. Okay, so that's solkatu. Here's some actual Konnakol musicians. That's BC Manjanath on the right, who I've been learning Konnakol from, or Konnakol rhythms recently. So yeah, let's have a listen. That's a shame. Yeah, I need to type that as well. So towards the end there, you maybe heard these repeated phrases getting shorter and shorter. That was a Tirmana structure, I believe. And you also noticed they were clapping a rhythmic cycle, quite a complex one. I'm not sure which one it was. But repeating it over and over again, I think at some point in this video they reverse it. But it's a very kind of geometric practice in these kind of rhythms grow and shrink over time. But there's always this underlying repetitive tala with the clapping underneath. So clapping the tala. In this presentation, I'll demonstrate the rapaka tala, which the kind of default one is just clap, clap, wave. And a wave is usually you actually just turn your hand over. So it's like a 3-step Tala, and the other one is Mishra Chapu Tala, which is a 7-beat Tala, but you go 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. So that's kind of the practice as far as I understand it, repeating these geometrical structures, reciting them while clapping. So this is one example in the Mishra Chapu Tala. Maybe you can see I've just got the numbers 1 to 7 here. Each step is like 1.5 beats, then 1 beat, then half a beat, and then half, 1, and 1.5, which you can also see in this code. So I've just made this function in Strudel and Tidal called expand, or step expand, where you can put in these sort of step durations, and then it will repeat them over time. Underneath it says wave, wave, clap, clap. That's the Tala. So this would be wave, 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 clap, clap. So something like 1, 2, 3, 4, 5. Yeah, I'm not sure if I'm going to be able to do this. So try again. 1, 2, 3, 4, 5. 1, 2, 3, 4. Yeah, let's try just with this. Oh, I'm going to have to. Yeah, this is going to be super annoying. So you can kind of hear that it goes out of the Tala, then back in again, just because if you add 3 times 7, then that obviously divides into 7. So with the sol katu, it would be something like ta, ki, ta, ka, de, mi, 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 ta. There, managed it. So, I think this is really nice. Like, it's very algorithmic, but it's also has a whole culture around it. So it's super interesting as someone developing live coding languages to be inspired by this kind of thing, and also get the sense that this is something you can do yourself. You don't need a computer. So when we get the solar flares that wipe out all our computers, we can still carry on. And so I've just generally got the, trying to take the approach where I'm not going to ask my computer to do algorithms anymore if I can't do them myself. Right, so here's another one. So here we were kind of expanding and contracting time. This is a Yati structure where you either add or subtract beats. So this is in Rapaka Tala, so it's clap, clap, wave. Maybe we could try and do this together, because it's quite nice to try and feel the beats move around while clapping. So if we do whack, clap, wave, clap, clap. Maybe slightly slower, actually, thinking about it. So rap, clap, wave, clap, clap. So 1, 1, 2, yeah. 1, 1, 2, 1. Hang on, I'm going to have to listen to it first. I'm a bit nervous. And also plug it in here. Live wiring. So 1, 1, 2, 1, 2, 3. Yeah, okay. Let's try again. 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 1. Yeah. So, tack, tack, tack. Tataka, takita, takadimi, tadigina, tom tadim, gina, tom tadim. Tom tadim, gina, tom tadim, gina, tom tadim, gina, tom tadim. Didn't quite manage it, never mind. It's much easier to do it when you're on your own when you're on stage, I find. So that's kind of, and here I've just made a taper function. So I'm tapering, adding, and then tapering by 1 to make it shrink again. So it's quite fun to try and come out with these structures that have this kind of geometrical, rhythmic approach, while still fitting an underlying kind of cyclic structure inspired by this kind of thing. So on to implementation. So Tidal and Strudel kind of very cycle-based, which is quite unusual for music technology stuff. So when you do any kind of operation, it tends to be relative to the metrical cycle rather than individual steps. So there's no real way of adding together 2 cycles of different length. You don't add beats together. You start with a cycle and then divide the cycle up. So if you try and concatenate 2 patterns, then this sort of thing will happen. So you can hear half of the cycle has got 3 things in, and the other half has got 4 things in, because that's what you end up with, begin with here. But now I've made this step cat function, which actually does take the number of steps into account, and so it will then sound like this. So that seems really simple, like just being able to add beats together, but actually you couldn't do that without kind of adding some extra maths in to shrink and grow them by the right amount, which is a bit odd. But the reason for that is that the underlying implementation is inspired by FRP. So a pattern is just a function from time, a time span to events active during that time. Each event has the time span within that query where it's active. Might be a fragment, so in that case, you have to have the whole event as well as the fragment that's active. And a time span is just a begin and end time, which is a rational number. So what you end up with is a representation, whereas a pattern is not a data structure, it's a function, it's completely opaque. You don't know how many steps are in there, and it might change over time, so you can't actually take... There's no way of finding out what's in there without querying it, and then it's too late. Because when you're manipulating a pattern, you're not actually dealing with the data within it, you're actually making a new function which calls the old function. So, and you don't actually query it until it's time to turn it into sound. I came up with quite a complicated way of fixing this by splitting the pattern into a type class with 2 instances, one functional and one based on the data structure, which was really fun. Took months sort of working through this, but then realized it was just too complicated. And in the end, I just went back to the original representation and added some metadata, which just says what the tactus of the pattern is, where the tactus is the clapping rate. So if you have a group of people listening to music, ask them to clap together. The idea is that the tactus is what they choose to clap. So it's not the number of beats, because it might be quite a complex structure, but it's kind of this perceptual idea of the tactus. What is that kind of feel? Which is ambiguous, but that's part of the joy of the tactus, I think. So I did tactus, and also something, the pure value, just for like efficiency. I won't go into that. There's some more details in the paper if you're interested. How am I doing for time, May?
Well, we did start a bit late, and we have to keep you opening Jack Audio Connection Toolkit. So I'll say, 3 or 4 more minutes.
Okay, I'll go super quickly. I'll just explain the joins. So often you'll end up combining 2 patterns by doing a functor map, and then the values doing something with that value with another pattern, and then you end up with a pattern of patterns, and then you have to join them somehow into a pattern again. So the normal join will just do this. Hey. So here we've got 2 patterns, which end up being a pattern of patterns, and then the join will just line them up, and then you can add together the values. But then you can also do an inner join, so just use the structure of the inner pattern. Or the outer join to use the structure of the outer pattern. Or a squeeze join to squeeze the structure of the inner pattern into the outer one. But now I know the tactus of the patterns, I can do something like a polymetric join, where the sort of steps are matched up over time. That's a bit fiddly, that syntax, but in Tidal and Strudel, patterns are numbers, so you don't have to do all that functor map stuff directly. You do have to wire up your jack. And then you can choose the different joins like this. Yeah, there's more details in the paper about how to choose what the tactus is, which you can do in the mini notation. There's another function called tour, which is where you can place a pattern at different points within a list of patterns. I was also thinking about demoing how to put this into practice, but luckily there's a whole concert on that later, and I'll be performing as part of that. So I'll just finish then by thinking about the kind of wider context of Konnakol. So this quote from T.M. Krishna: "In all Indian musical traditions, learning, rationalization, and sharing are part of the internal process within and between artists. The magnificence of this non-scribal technique is the acceptance of diversity and the possibility of continuous musical change. At no point is the music etched in stone, trapped in time, a stone tablet of commandments." I think this is a really beautiful idea, and I think there's something really special about oral traditions which aren't so focused around notation. And it's quite a strange sort of inspiration for something like live coding, which is so notational, but it's also very kind of ephemeral. If code is only made to be changed and deleted at the end of a performance, then it is becoming more like speech in a way. And I think it's nice to think about how we can move beyond this sort of this idea of algorithmic music being tied to the score or software engineering or something like that, thinking of something that's much more about exploring ideas live and with our friends for the moment. So yeah, thank you for your attention.
So we can take questions while we load up the video. Our next talk is going to be pre-recorded because the speaker is undergoing a medical procedure.
Any questions? No.
So I loved how the various joins sounded, but I wasn't quite sure how they worked. So in an inner join, you have this kind of pattern, and then you have you've sort of joined it with another pattern, and it's moving through both at the same time in a way I'm not sure I quite understand. Is it okay?